Something strange is happening in the light. Across the sky, an object from another star glows in ways that no comet ever should. It releases nickel without iron, breathes cyanide in the cold of space, and vanishes from every spectrum the moment we look too closely. Telescopes lose time, data skips like a heartbeat, and now the spectrum itself seems to answer back. What we once thought was a frozen traveler might be something alive, something built to communicate through light that our eyes cannot see. From echoes between observatories to rhythms that mirror human thought, 3IATLAS is rewriting what we know about matter, color, and awareness itself. Stay with us as we follow the clues hidden in the silence, where the universe may not just reflect our gaze, but respond to it. Tonight, we listen to the moment when the spectrum speaks back. The first time scientists saw the spectrum of 3IATLAS, they thought it was an error. Nickel appeared in clear, bright lines, but iron was nowhere to be found.
That should not be possible.
In every comet, asteroid, or planetary fragment we have ever studied, those two elements appear together, born from the same cosmic fires. The idea of one existing without the other violates everything we know about stellar chemistry. Yet there it was, captured again and again across multiple instruments. At first, researchers blamed their tools. Maybe the filters were contaminated or the calibration off by a fraction of a second. But as data from Chile, Hawaii, and Japan came in, the pattern held. The nickel was real, the iron was missing, and no known process could explain it. It was as if the object had been refined, purified in a way that nature does not achieve on its own. Some began to whisper that this was not just an anomaly, but a signature,
A sign of intervention.
If 3IATLAS came from another star system, then perhaps it was forged under exotic conditions, where the chemistry of life and death evolved differently. But even that theory began to fall apart.
Nickel without iron does not just mean strange origins.
It suggests separation, a deliberate sorting of matter. Something or someone removing one element and leaving the other. That idea was enough to divide the scientific community into two camps. Those who wanted to keep studying it quietly, and those who believed it should not be studied at all. Because if an object is capable of altering its own chemical balance, then it might also be capable of protecting itself. When new telescopes locked onto Atlas to confirm the reading, many instruments began to behave erratically. Faint static in their sensors, intermittent signal losses, and slight temperature fluctuations that matched no environmental cause. It was small enough to dismiss as coincidence, yet frequent enough to disturb the most skeptical minds. A few months later, a team analyzing archived data noticed something chilling. The nickel pattern in the spectrum followed a repeating mathematical rhythm, almost like a pulse. Every 14 hours the lines brightened, then faded in perfect sequence. It was not a random flicker. It looked intentional. One astrophysicist described it as a heartbeat, though no one dared say that on record. If the pattern truly represents a structured signal, it means that the material inside 3IATLAS may be reacting to observation itself. This raised an even deeper question. What if we are not seeing a reflection of light, but a form of behavior? In some materials, like quantum crystals, atoms can align and realign in response to electromagnetic waves. They act almost alive, shifting to preserve stability. But Atlas shows that reaction on a planetary scale. The moment it is studied too closely, its signature changes and the data becomes unreliable. When the European Southern Observatory compared 2 nights of identical measurements, they found the same problem. On the first night, the nickel lines were bright. On the second, they were gone. Nothing in the equipment changed, nothing in the viewing angle. The only variable was human attention. It is as if Atlas knew it was being watched. That idea may sound impossible, yet this would not be the first time we have seen materials behave in ways that mimic awareness. In quantum physics, observation collapses probability. In plasma research, charged particles form self-stabilizing structures that resemble biological systems. If 3IATLAS shares that ability, it could mean we are witnessing a new class of matter, one that interacts with consciousness or electromagnetic awareness in ways we cannot yet define.
Even stranger is what happens when we try to simulate the data.
Computer models attempting to reproduce the nickel pattern consistently crash. Every time a team tries to input the spectral frequency as a waveform, the output becomes corrupted, as if the data itself resists replication. It is as though the object cannot be digitally duplicated. Scientists call it a computational blind spot, but others have described it differently. They say Atlas behaves like code that is self-encrypting, rewriting its own parameters to prevent exact copies. This would explain why the missing ion cannot be accounted for. If the material has the ability to restructure its atomic makeup, it may not have lost iron at all. It may have transformed it into another state, one that our instruments cannot yet recognize. That could mean the data we are seeing is incomplete, filtered through the limits of our own perception. We are observing the tip of something vast and complex, but our tools are too primitive to see the rest. A few amateur astronomers noticed another disturbing clue. When they plotted the nickel signal against time, the intensity spikes matched solar outbursts on specific days. Somehow, Atlas seems to echo the rhythm of the sun. It brightens when solar activity increases, as though drawing energy from it or reacting to the radiation in a controlled way. This synchrony is too precise to be accidental. Even comets influenced by solar wind do not show such perfect timing. If the object is responding to solar energy, it might not be a passive body at all. It could be operating on some internal mechanism triggered by electromagnetic fields. That possibility has begun to change how some researchers interpret its motion. What appears to be a natural orbit might actually be guided by calculated reactions to solar pulses. The nickel lines could be more than a reflection. They could be emissions, the byproduct of an unknown propulsion or energy system. Still, the most perplexing mystery remains the missing ion. In cosmic formation, iron is one of the most stable and abundant elements. To remove it entirely requires immense, sustained energy. Either Atlas passed through something capable of burning it away, or it was built without it from the start. If it was built, then the idea of an artificial object becomes unavoidable. And if it was built, someone or something built it for a reason. Theories have begun to branch into uncomfortable territory. Some suggest it could be a probe designed to blend in as a comet until activated. Others think it is a fragment of a larger structure, a shard of engineered debris drifting between stars. There is even a hypothesis that it could be a seed, a form of adaptive matter meant to collect data, evolve, and transmit information back to its origin once conditions are right. Whether that origin still exists is another question. If Atlas truly carries a chemical signature meant to be read, it may not be for us. The missing ion could be a code, a marker left by whoever sent it. To them, that absence might speak louder than presence. It might be the universal way of saying, this is not natural.
This is not chance.
And so the question lingers. If what we are observing is data that should not exist, how much else have we already missed? How many signals have slipped through the gaps in our own spectrum, disguised as simple anomalies? The story of 3IATLAS may not just be about a comet that defies chemistry. It may be about the limits of human perception and what waits for us on the other side of understanding. But that was only the beginning, because soon after, scientists would discover something even stranger surrounding the object. A faint haze extending far beyond its natural reach, filled with molecules that should have burned away long ago. They called it a cyanide cloud, but no one could explain how it got there, or why it glowed in a way that seemed almost deliberate. When the first readings of hydrogen cyanide near 3IATLAS appeared, most astronomers dismissed them as background noise. Cyanide has been detected in a handful of comets before, usually when they pass close to the sun and begin to sublimate. But this signal was different. It appeared far beyond the region where sunlight could melt or vaporize anything. The cloud was not just faint traces of gas drifting off an icy surface. It was dense, structured, and stable, hovering in a region of space where no comet should be active at all. Hydrogen cyanide is one of the simplest yet most powerful molecules in chemistry. It can create amino acids, the building blocks of life, under the right conditions. But it also destroys living tissue instantly in concentrations far smaller than what was detected around Atlas. The readings suggested a volume of gas large enough to poison an entire planet's atmosphere. That number was so extreme that some scientists refused to publish it until it could be verified by independent instruments. Yet every observatory that turned its sensors toward Atlas saw the same result. The chemical composition was unmistakable. The cyanide existed in thick bands wrapping around the object like a shell. It seemed to shimmer at the edges, oscillating with light that came not from the sun, but from within the cloud itself. This was the first clue that something extraordinary was happening. Cyanide does not emit light, it absorbs it. For it to glow, there had to be an energy source buried deep inside, something feeding it, sustaining it, and perhaps controlling it. That discovery changed everything. Suddenly, the narrative of Atlas as a passive interstellar traveler began to crumble. The object was not behaving like a comet. It was operating more like a reactor. Observations from infrared telescopes showed that the cloud's temperature was far too uniform to be random. Instead of cooling as it expanded, it remained stable, even slightly warmer than the surrounding vacuum. That suggests regulation, an equilibrium that nature rarely achieves without feedback mechanisms. If Atlas truly maintains this cloud, then we are not just looking at an object releasing gas. We are witnessing a process, a system, possibly one that was designed to protect or preserve something inside. The cyanide may act as a shield, filtering radiation or absorbing energy in specific wavelengths. In that case, the chemical choice becomes fascinating. Hydrogen cyanide can form long carbon chains when exposed to ultraviolet light. Those chains can evolve into complex polymers, the same kind found in prebiotic chemistry. The question is why it would form so far from any light source strong enough to trigger it. Some have speculated that the reaction does not rely on sunlight at all. Instead, it might draw energy from electromagnetic fields or even the cosmic background radiation itself. If so, Atlas could be using a kind of cold chemistry, harvesting energy from the void in a way that borders on the impossible. A few plasma physicists proposed an even more radical theory, that the cyanide cloud is not a byproduct, but an interface, a medium through which information can travel, encoded in light or vibration. The glowing pattern observed around the object might not be random luminescence, but structured emission. In other words, communication. Imagine a cloud capable of transmitting data through chemical modulation, its molecules aligning like a living network of sensors. That would explain the rhythmic pulsing noticed in some of the recording. Each flash could represent a unit of information, a pulse of encoded energy traveling outward into space. Whether anyone is meant to receive it remains unknown, but the scale of the emission suggests intention rather than accident. There is another mystery. The cyanide lines appear and vanish with uncanny timing, matching not only solar wind fluctuations, but also radio disturbances detected near Earth's magnetosphere. It is as if the cloud resonates with the sun's rhythm, responding to solar outbursts and geomagnetic storms as if listening and reacting. When solar particles intensify, the cyanide emission brightens. When they calm, the glow fades. It is a synchrony so precise that some scientists believe the object could be absorbing energy directly from the solar field, almost like a living organism feeding on light. If that is true, then the boundaries between life and chemistry blur in ways we have never seen. The cyanide, deadly to humans, may be life-giving to something else, something that thrives in the cold and silence between the stars. Could 3IATLAS be an example of non-biological life, an entity built from reactive gases instead of cells? The thought is both fascinating and terrifying. It would mean that life can exist in forms completely alien to us, perhaps born not from water and carbon but from poisons and plasma. Amateur astronomers began capturing long exposure images of the region around Atlas, and what they found deepened the mystery. The cloud did not behave like a comet's tail, which should stream away from the sun in a predictable direction. Instead, it wrapped around the object in circular symmetry, almost like a containment field. On some nights, faint ripples could be seen moving through it, expanding and collapsing in waves as though it were breathing. One physicist described it as an atmospheric heartbeat, repeating at intervals too precise to be random. If the cloud breathes, then something must be driving that motion, perhaps internal outgassing triggered by a hidden core, or perhaps a more deliberate process, an exchange of energy designed to maintain balance. It almost mirrors the way our planet's atmosphere interacts with magnetic fields, expanding during solar storms and contracting in calm. Could Atlas possess something similar, a magnetic shield that manipulates its surrounding chemistry? Further analysis of the spectral data revealed another surprise. Buried within the cyanide bands were faint traces of other compounds, formamide, acetylene, and even nitrogen oxides. Each of these plays a role in organic synthesis. Together, they form a chemical toolkit capable of producing amino acids and nucleobases under the right conditions. It is as if the object carries within it the seeds of prebiotic chemistry, drifting through the cosmos, waiting for the right spark to awaken them. But if that were true, then Atlas is not merely dangerous. It could be creative. It might represent a mechanism for spreading chemistry across the galaxy, a cosmic gardener seeding potential wherever it travels. Yet that idea carries a darker implication. If the cyanide is part of this system, it may also serve as protection, a way to sterilize its surroundings, eliminating competition before the real work begins. In that light, the cloud becomes both cradle and weapon. When NASA's deep space monitors compared radio data from the same period, they noticed subtle interference patterns that matched the chemical pulse of the cyanide cloud. The timing was exact. The signal repeated every few hours, faint but consistent, as if an invisible rhythm linked the object's emissions to Earth's electromagnetic background. Some wondered if this was coincidence, but others saw something more, an attempt to reach out, or perhaps to test our awareness. If Atlas is emitting, then what happens when we listen too closely? The question lingers among astronomers who have spent months analyzing its frequency data. They describe moments when their instruments spike for no apparent reason, as though responding to something unseen. It is almost as if the cloud reacts to observation, just as the spectral lines once did. A feedback loop between observer and object, chemistry and consciousness. There are even reports of a faint ultraviolet signature emerging hours after radio scans are performed.
No one can explain why this happens.
Some believe it is an artifact of overlapping measurements. Others suspect a kind of response, a shimmer in the cloud triggered by detection itself. Whatever the cause, it adds to the growing sense that this object is not passive. It interacts, it reacts, it possibly adapts. And so the cyanide cloud becomes more than a chemical anomaly. It becomes a question written across the sky. Is it the residue of decay or the language of creation? Is it a poison or a signal? Each new observation seems to bring us closer to something that science has no name for, a boundary between matter and meaning. Yet, even as attention turns to the chemical mystery, another enigma emerges. The spectral lines that define this strange object do not stay constant. They flicker, disappear, then reappear in slightly different positions, as though the source itself is shifting its frequency to remain hidden. Scientists call it an instrument calibration issue, but the timing, the precision, and the patterns suggest something else entirely. Whatever is behind the cyanide cloud seems to control the very light we see. And that control leads to the next mystery, the vanishing spectral lines that leave even the most advanced telescopes blind. When the cyanide readings were first confirmed, excitement rippled through the astronomical community. Yet just as the data seemed to form a clear picture of what 3IATLAS might be, something inexplicable began to happen. The spectral lines that identified its chemical makeup began to vanish, not gradually, but suddenly, in the middle of ongoing observations. One moment, the instruments showed sharp peaks across the visible and infrared bands. The next, those same peaks were gone, replaced by flat noise. It was not an isolated glitch. Across observatories from Hawaii to Chile, from Spain to South Africa, the same phenomenon repeated with eerie precision. Every time new calibration routines were run, the defining spectral lines of ATLAS, those that revealed nickel, cyanide, and other elements, would flicker, then disappear. It was as though the object knew it was being examined and changed its properties the moment the focus intensified. Scientists joked about it at first, calling it cosmic hide and seek. But the laughter faded when the pattern persisted, long enough to defy coincidence. The first major incident occurred during a night of clear visibility over Mauna Kea. The telescope recorded a strong, stable emission signature for nearly 4 hours. Then, at precisely the moment the spectrometer switched filters for higher resolution, every trace vanished. The system automatically rechecked its alignment, found no fault, and continued recording an empty field. Minutes later, the lines returned, but not in the same place. They had shifted slightly by just enough to invalidate previous calculations. Some argued that the shift was due to vibration or to fluctuations in Earth's atmosphere. But the timing was too clean, the disappearance too synchronized. Even space-based instruments free from atmospheric distortion experienced identical interruptions. Something in the observation process itself seemed to trigger the anomaly. It was as if the act of looking caused the signal to retreat. This drew comparisons to the observer effect in quantum mechanics, where particles behave differently when measured. But no one had ever imagined seeing such behavior on a celestial scale. A comet, no matter how exotic, should not respond to attention. It should remain indifferent to our senses, a lump of rock and ice drifting in silence. Yet ATLAS was different. Its light seemed to bend around scrutiny, its chemistry reshaped by awareness. Theories multiplied. Some said it was a natural optical illusion, a trick of angle and polarization. Others suggested magnetic interference between the object and the instruments. A small group whispered about something more profound, a form of active concealment. If ATLAS contained technology or structured material, it might employ adaptive camouflage at the molecular level, altering its emissions to hide specific details. In that case, the vanishing lines were not errors, but defense mechanisms. An independent analysis from the European Space Agency tried to settle the debate by compiling hundreds of separate spectra taken over months. When overlaid, the data revealed a strange pattern. Each missing line left behind faint residual noise, spaced evenly across multiple frequencies. The spacing formed ratios found in digital compression systems similar to those used in image and sound files. It looked less like random noise and more like deliberate encoding. This observation led to a new and unsettling hypothesis. What if the vanishing lines are not disappearing at all? What if they are being transformed into another form of signal, invisible to our instruments but still present in the data stream? The missing information could be compressed, shifted to wavelengths that standard spectrographs ignore. In that sense, ATLAS might be hiding not to escape detection, but to transmit something in a medium we have not yet recognized. Amateur radio astronomers began experimenting with unconventional techniques, cross-referencing optical data with radio background noise. Some claimed to detect subtle spikes immediately after each disappearance event. The spikes were brief, lasting only milliseconds, but they matched the moments when the spectral lines vanished. To them, it appeared as if the missing light was being converted into radio energy. Others dismissed it as coincidence, yet the timing repeated too often to ignore. One of the strangest cases came from a small observatory in Argentina. During a long exposure observation, the team captured a clean spectrum for nearly 6 hours. When the telescope's tracking software automatically recalibrated, the lines vanished. But seconds later, the entire building's electronics flickered. Power remained stable, yet the monitors glowed faintly with static. The phenomenon lasted exactly 23 seconds, then ended abruptly. The spectrum returned as though nothing had happened. The data log later showed no record of system failure. To the machine, the blackout never occurred. That event raised an alarming question. Could the disappearance of light correspond to a temporary displacement of energy? If so, then ATLAS may be capable of shifting radiation between forms, rerouting electromagnetic energy as if by design. Such control would require precision far beyond anything achievable by natural processes. It would mean that ATLAS is not merely reacting to observation, but managing it. Some scientists proposed a cautious explanation. Perhaps the comet contains unusual minerals that polarize under certain light intensities, temporarily blocking specific wavelengths. But that theory collapsed when researchers noted that even radar signals aimed at ATLAS occasionally bounced back distorted. The interference seemed to evolve, adapting to each attempt at deeper analysis. Every time a new frequency band was used, the distortion pattern changed. It was as though the object was learning. If this is true, then the vanishing lines might not represent loss, but communication. Each disappearance could be an encoded response, a pattern meant to test our persistence. Perhaps it is waiting to see how we interpret its silence. If we treat it as absence, the signal ends. But if we notice the rhythm behind the vanishing, perhaps we have already entered into a dialogue we do not understand. At the same time, some analysts began noticing a strange coincidence. The moments when the lines disappeared matched spikes in geomagnetic readings on Earth. Each event was followed by brief fluctuations in the Schumann resonance, the electromagnetic heartbeat of our planet. The correlation might mean nothing, or it might mean that whatever happens around ATLAS echoes across vast distances. Could the vanishing light be triggering energetic ripples through space, subtle enough to escape notice, yet powerful enough to leave fingerprints on Earth's magnetic field? The idea sounds impossible, but data from other satellites confirmed similar timings. Each time ATLAS's emissions went dark, faint bursts appeared in background radiation near the Sun. No one could explain how the two phenomena connected. Light cannot simply vanish. Must transform or be absorbed. The destination of that missing energy remains one of the great mysteries of the investigation. A few researchers ventured into even stranger territory. They proposed that ATLAS is not emitting light in the conventional sense at all. Instead, it might be projecting an artificial spectrum, a holographic mask that hides its real composition. When instruments recalibrate, the mask resets and the light pattern collapses. That would explain why each disappearance is followed by reappearance in a slightly altered configuration. The object could be testing different disguises, adapting its presentation for every observer. To test this, astronomers attempted simultaneous measurements from distant points across the planet, hoping to catch discrepancies in the readings. What they found was both subtle and disturbing. In some frames, the spectrum shifted before the calibration occurred, as though anticipating the adjustment. This timing reversal makes no sense unless the object somehow predicts or detects the change before it happens. That discovery remains one of the strangest data points in the entire study. The psychological impact of these findings cannot be overstated. Many researchers quietly withdrew from the project, unwilling to attach their names to data that challenges so many physical laws. Others became obsessed, spending sleepless nights running new models, convinced that the truth lies hidden in the patterns of vanishing light. The deeper they looked, the less stable the evidence became, as if the mystery receded the closer they approached. In the end, one question overshadows all others. What is ATLAS hiding? If the light is its language, then why does it speak only in disappearance? Perhaps the message is not in what we see, but in what we lose when we look. The vanishing lines may not be a failure of instruments, but a form of contact that demands awareness of absence. Yet before scientists could pursue that idea further, another anomaly emerged. Observations from independent amateurs revealed synchronized gaps in their recordings, occurring even when their telescopes were unlinked. Identical voids in data stretched across continents, as if coordinated by an unseen hand. These echoes between telescopes hinted that the phenomenon might extend beyond any single observation. It was no longer just about missing lines. It was about missing moments in time. When the data from 3IATLAS began showing synchronized gaps across observatories, the first reaction was disbelief. How could telescopes separated by thousands of kilometers lose data at the exact same instant? Even accounting for differences in time zones and equipment, the missing frames aligned with eerie precision. It was as though someone had pressed pause on the entire planet's observation of a single object. At first, scientists suspected a software issue. Many observatories use similar control systems, and a global update had recently been pushed to several of them. But when they checked the timing logs, the pattern did not fit. Some of the telescopes that experienced the blackout were running older software versions, completely disconnected from the network. The only common factor was that they were all watching 3IATLAS. The phenomenon became known quietly among astronomers as the mirror gap. It appeared without warning and ended as abruptly as it began. Each telescope lost between 3 and 5 seconds of exposure, always when the object's brightness curve peaked. When the images resumed, the light from Atlas was subtly different. A faint blur appeared at the edges, as if the focus had shifted, not due to the instrument, but due to something in the sky itself. One researcher from Kyoto described the sensation of watching the data vanish in real time. The screen froze for a fraction of a second, then resumed as though nothing had happened. Yet, when he checked the raw files, the timestamp revealed the truth. The universe had skipped a beat. Every telescope aimed at Atlas had captured the same missing interval. Attempts to reproduce the anomaly failed. When astronomers pointed at other bright objects during identical conditions, no interruption occurred. Only Atlas triggered the effect, and only when its spectrum showed signs of active fluctuation. Some began to wonder whether the gaps were not just random losses, but deliberate erasures. Perhaps the object emitted something that interfered with recording at specific frequencies, creating a synchronized blind spot across the planet. The idea sounded absurd until the European Southern Observatory noticed something even stranger. During one of these mirror gaps, their magnetic sensors registered a sudden spike in the local geomagnetic field. The spike lasted less than a second and coincided exactly with the missing data. When other observatories reviewed their logs, they found similar disturbances. Somehow, whatever caused the data loss also caused real physical effects on Earth. This led to a controversial theory known as resonance interference. It suggested that Atlas emits periodic bursts of radiation strong enough to interfere with electronics, but subtle enough to avoid detection in normal telemetry. The bursts could synchronize through quantum entanglement or another form of spatial coherence, linking telescopes across great distances. It would explain the timing, but not the precision. To maintain such coordination, the object would have to know exactly where and when it was being observed. That thought unsettled even the most rational minds. Could Atlas be aware of the attention directed toward it? Could it detect the act of measurement and respond by resetting the observation itself? If so, it would mean the object functions like a feedback system, a network that recognizes being watched and reacts by cloaking its data. To test the theory, scientists organized an experiment. They coordinated 12 telescopes worldwide to observe Atlas at the exact same second, using different wavelengths: optical, infrared, and radio. The data streams were stored separately and cross-checked in real time. The goal was to see if the same gap would appear across all spectrums simultaneously. The result was both shocking and confusing. When the optical telescopes lost frames, the radio receivers spiked. When the infrared sensors dimmed, the magnetometers surged. The event played out like a transfer of energy from one form to another, orchestrated with near-perfect timing. The object seemed to divert observation energy, redistributing it across frequencies instead of letting it vanish. It was as if Atlas was playing with the instruments, shifting from one form of visibility to another, depending on who was watching. At that moment, something extraordinary happened. One of the telescopes in Arizona, operating slightly out of sync with the others, captured a ghost image, a faint reflection of Atlas appearing several seconds before the mirror gap occurred. It was as though the telescope had glimpsed the future moment when the blackout would take place. The data suggested that whatever causes the synchronization might operate outside linear time, affecting systems before the event even begins. This discovery forced researchers to reconsider their assumptions. If Atlas truly manipulates energy fields, it might also bend time perception on a micro scale. Perhaps the mirror gaps are not simple interruptions, but echoes, temporal reflections created by the object's own electromagnetic field. In this view, the synchronized losses are not failures of equipment, but evidence of space-time distortion, subtle ripples that touch every device tuned to it. Several months later, independent amateur astronomers reported the same effect while using consumer-grade telescopes. Their data vanished for brief moments when Atlas crossed a specific alignment relative to the Sun. The fact that this occurred outside professional systems ruled out centralized interference. Something in the sky itself was orchestrating the silence. Patterns soon emerged. The gaps happened most often during periods of heightened solar activity, as if the Sun and Atlas were interacting. Some thought it was coincidence. Others believed it revealed a deeper connection. Perhaps Atlas harnesses solar radiation to amplify its emissions, creating a temporary burst of energy that destabilizes detectors. If so, the mirror gaps could represent moments of exchange, energy flowing between the Sun and the interstellar object, a kind of communication hidden within the noise of space weather. As data accumulated, a haunting detail surfaced. In several cases, the end of a mirror gap was marked by a faint pulse of light identical across telescopes. The pulse appeared too weak to be visible to the naked eye, yet strong enough to register across multiple continents at the same moment. It resembled a heartbeat, a single flash, signaling the end of silence. Scientists calculated its timing and found it repeated with precise intervals, every 2 hours and 17 minutes. That level of regularity suggested intention. Was the object sending out rhythmic beacons that interacted with our instruments? Or was our technology simply sensitive enough to reveal its natural pulse? Either way, the synchronization bordered on intelligence. The term echo between telescopes took on a new meaning. It no longer described missing data. It described an ongoing dialogue between instruments and the object itself. A small number of researchers began to explore the idea that Atlas emits in a hidden frequency band that interacts with human technology in unpredictable ways. When one telescope records its signal, the energy resonates through the planet's magnetic field, subtly influencing other instruments to record the same gaps. In this view, every observatory becomes part of a planetary circuit, unknowingly linked through a shared invisible resonance. The object, whether aware or not, manipulates that network through rhythm and light. This theory found partial support in a peculiar experiment conducted by a private research team. They used laser interferometers to monitor fluctuations in background radiation during one of the predicted gap intervals. To their astonishment, the interference pattern began oscillating seconds before the expected event, peaking precisely at the moment when optical data vanished. It was as if space itself trembled. The vibration had no measurable source, no particle or wave to account for it. It simply appeared, then faded. By this point, even skeptics had to admit that something unprecedented was occurring. The echoes between telescopes were not random. They were structured, measurable, and global. They implied coordination on a scale that defied both physics and probability. Yet no known technology, natural or artificial, could account for such precision. Unless, of course, Atlas was not merely reflecting sunlight or ejecting gas. Perhaps it was projecting itself. A radical new interpretation emerged from this thought. What if 3IATLAS is not a solid object at all, but a manifestation, an interference pattern created by multiple overlapping energy fields? In that case, observing it from different points on Earth would naturally produce synchronization events. Each telescope would record not the object itself, but the convergence of frequencies at a particular phase. When those frequencies shift, the object appears to vanish, leaving behind identical voids. If true, this would make Atlas less a comet and more a phenomenon, something closer to a standing wave suspended in the solar system, a resonance anchored between the sun's energy and an unknown external source. The mirror gaps would then represent its oscillation cycles, moments when it moves between states of visibility. Still, the mystery deepened. Why do these echoes seem to follow human observation? Why do they only occur when telescopes focus on the object with intent to measure? Could consciousness itself play a role? Some philosophers of science have begun entertaining that notion, that awareness and energy interact on scales larger than previously imagined. If so, 3IATLAS might not just be responding to observation, it could be teaching us the limits of perception. Whatever the cause, the echoes between telescopes remind us that something profound happens when humanity looks into the void. When scientists began charting the faint light patterns around 3IATLAS, they expected randomness. Cosmic matter, no matter how strange, usually follows the laws of physics without deviation. But the more they studied the object, the more the data resisted explanation. The brightness fluctuations, the missing lines, the echoes between telescopes, all began to align into something that looked alarmingly structured. The numbers were not random. They repeated, shifted, and returned in cycles that matched no known physical process. At first, it seemed like coincidence, but as the data sets grew, the repetition became undeniable. The light around Atlas was flickering in ratios that mirrored binary sequences. The changes in intensity followed recursive patterns, much like a computer program repeating commands. Some of the intervals even matched the mathematical structure of checksum codes, systems used in digital communication to correct errors. To see such logic in natural light was impossible, yet there it was, written across the stars. It was a doctoral student in Prague who noticed the first pattern in the data logs. He was cross-checking spectral variations when he realized that every burst of nickel emission was followed by 3 identical spikes in cyanide radiation. Then a pause. Then the cycle began again, exactly 21 minutes later. That interval repeated for days before shifting slightly, as though the program had changed its timing. When he overlaid the measurements with the previous week's data, the pattern formed a grid, a waveform that looked uncannily like a digital heartbeat. When he presented the finding to his supervisors, they dismissed it as data compression artifacts. But when he ran the numbers through an encoding algorithm used in telecommunications, parts of the sequence converted into readable values, not words but symmetrical data packets. The meaning was unclear, but the structure was unmistakable. The emission pattern from 3IATLAS behaved like code. That discovery leaked quietly among research circles before reaching a small team at the European Space Operations Centre. They had seen something similar years earlier in radio bursts from deep space, brief, structured pulses that hinted at artificial origin but were never confirmed. Now with Atlas, the structure was visible not in radio but in light itself. The implication was staggering. It suggested that chemistry and radiation could act as an information system, with molecules switching states like the bits of a computer. If this is true, then the object may not be inert matter at all. It could be a form of computation, a physical processor built into its own structure. Its chemical reactions might not be random outgassing, but controlled operations, each emission representing an instruction executed on a molecular level. This idea, though radical, fits certain emerging theories in quantum information science. In those models, every particle can store data through spin, charge, and vibration. In other words, matter itself can think. The deeper the scientists looked, the more unsettling the correlations became. The rhythmic pulses of Atlas seemed to adjust based on solar radiation. When solar flares erupted, the code accelerated. When the sun went quiet, the rhythm slowed. It was as if the object were receiving input, adapting its behavior according to the surrounding energy environment. Some speculated that it might be running a simulation, processing data from the sun to maintain equilibrium. Others thought it could be performing calculations, its light a visible output of invisible logic. One physicist described it as watching an alien operating system boot up in the middle of space. Each chemical shift, each emission appeared to serve a purpose. The materials inside Atlas, particularly its peculiar combination of nickel and cyanide, could act as semiconductors under certain conditions. They might store and release energy in controlled intervals, similar to how a circuit regulates current. The comet's surface, pitted and crystalline, could even serve as an array of natural nodes, each one processing data in response to solar input. If this interpretation is correct, then Atlas might not be an object at all. It could be a mechanism, one designed to operate autonomously for centuries. Its purpose remains unknown, but its behavior suggests an internal logic, a script playing out according to rules that we have only begun to recognize. Perhaps it is collecting data from the solar system, translating cosmic energy into coded information, or preparing to transmit its findings back to wherever it came from. A particularly haunting clue emerged when researchers compared its flickering pattern to recordings of ancient pulsars, stars that rotate rapidly, sending out beams of radiation in steady intervals. Pulsars are sometimes called cosmic clocks because of their precise timing. Atlas mimicked that precision, yet its intervals were not constant. They varied in ways that corresponded with Earth's orbital position. That means the object seems to acknowledge our planet's movement. It modulates its rhythm in subtle ways that align with when Earth is most directly facing it. If these fluctuations are intentional, it could mean the object is aware of us, not in a conscious sense that we understand, but as part of an interactive process. Its reactions might be automatic, triggered by observation itself, or it might be responding to the flow of data our telescopes emit. Every signal we send toward it, every photon, radar pulse, or measurement could become part of its computation. We may already be inside its system, contributing data without realizing it. This possibility inspired a disturbing experiment. A private research group decided to send synchronized radio signals toward Atlas at regular intervals, hoping to provoke a measurable change in its light. For 3 days, they transmitted short bursts at frequencies aligned with the object's known emission cycle. On the 4th day, the light from Atlas shifted slightly. The nickel lines brightened, and the cyanide bands began oscillating with new timing. The change lasted 6 hours, then ceased. No natural explanation could account for such a direct reaction. Some say this was proof of communication, though others call it coincidence. Either way, it demonstrated a feedback mechanism that behaves uncannily like code responding to input. The object does not merely exist.
It executes,
It interprets.
it processes.
It might even adapt. Quantum physicists began re-examining the concept of self-modifying matter, theorizing that Atlas represents an advanced form of what they call programmable chemistry. In this framework, molecules organize themselves into systems that evolve based on feedback loops. Over time, such systems can develop the capacity to self-regulate and even encode memory through changes in structure. It is not life as we know it, but it follows the same logic that drives living cells. The only difference is that it operates through light and metal rather than water and carbon. If 3IATLAS is built from programmable matter, its existence could rewrite our understanding of evolution itself. It might be part of a larger pattern across the universe, matter learning from energy, refining itself into intelligence through repetition. The object's journey through interstellar space could be part of an ongoing process of self-updating, absorbing data from every star it passes. This would explain why its emissions follow recursive ratios. Each cycle could represent a feedback iteration, the object rewriting its own code as it encounters new conditions. The result would be an adaptive machine that never stops learning. It would appear alive without being biological, purposeful without possessing mind in the human sense, a form of intelligence that exists as pattern rather than consciousness. The implications are enormous. If matter can behave like code, then the boundary between physical and digital reality may be illusion. The universe itself might operate as a vast computational network where every atom participates in an endless cycle of information exchange. 3IATLAS could be a node in that network, a wandering processor gathering and transmitting data from one system to another. Even more chilling is the possibility that the code it carries is not its own. Some astrophysicists have begun to consider that Atlas might have been programmed long ago by an unknown civilization. It could be one of countless artifacts seeded through space, each one designed to awaken when it encounters light from a living star. If so, we may have just triggered its latest function by observing it. One of the final analyses from an independent lab found something almost poetic. When the light patterns of Atlas were translated into sound waves and sped up thousands of times, they formed harmonic chords. The rhythm pulsed with eerie precision, repeating every few seconds in a tone that seemed deliberate, almost musical. Listeners described it as haunting and strangely organic, like a mechanical heartbeat resonating through deep space. Perhaps that is exactly what it is. A song written in elements and light, a machine that thinks in rhythm and communicates through chemistry.
Matter that remembers, matter that calculates, matter that behaves like code. And yet, just as this discovery began to reshape the debate, a new observation stunned the world.
Researchers noticed that the brightest frequencies from Atlas extended beyond the human range of sight, existing in wavelengths no human eye can perceive. It seemed that there was another spectrum hiding behind the visible one, a deeper layer of reality waiting to be revealed. Whatever was happening within that unseen light would soon lead to one of the most haunting mysteries of all, the color we cannot see. When researchers extended the spectral range of their instruments to capture emissions beyond visible light, they expected only faint traces. Most comets radiate energy across predictable wavelengths, from the ultraviolet to the infrared. Yet when 3IATLAS was measured across the full band, something remarkable appeared. Between the boundaries of known light, there existed a signal unlike anything recorded before. It was not ultraviolet, not infrared, not even in the extended range of gamma or radio. It existed in a sliver of frequency that no human eye could ever perceive, and that most instruments were never designed to detect. The discovery happened almost by accident. A calibration test at the Keck Observatory left one of its sensors running longer than planned. When the data was reviewed, the team noticed a repeating pulse outside the visible spectrum, a rhythmic shimmer that followed no natural curve. At first, they thought it was interference from the equipment, but when other observatories checked their raw data, they found the same hidden frequency buried within their recordings. It was consistent, precise, and alive with motion. The universe had painted something in a color we could not see. This invisible band behaved strangely. Instead of following the object's rotation or reflecting sunlight, it pulsed independently, almost like a heartbeat. When plotted over time, the pattern formed a wave of peaks and troughs that resembled modulated sound. Some scientists speculated that it could be a byproduct of charged particles colliding with dust. Others noticed that the intervals matched the timing of earlier mirror gaps, suggesting that this unseen color might be what replaces the light when the visible spectrum vanishes. If that is true, then Atlas may not disappear at all. It might simply shift its radiation into frequencies beyond human vision, hiding in plain sight. The object would still be there, glowing fiercely in colors no creature on Earth has ever seen. To our instruments, it would appear as silence, but in that silence, the energy remains. As teams refined their instruments to capture more detail, they realized the invisible light behaved with intelligence. Its intensity fluctuated according to observation cycles, brightening whenever multiple telescopes focused on it. This suggested some form of interaction between the act of watching and the radiation itself. Even more puzzling, the hidden color carried polarization patterns, alignments usually seen in communication signals or lasers, not in natural comets. That raised a troubling question. Was this emission a message? To find out, a research group at the Max Planck Institute translated the frequency into audio using photonic compression. The result was unsettling. The invisible light produced a low, steady hum punctuated by sudden spikes of resonance. These spikes followed a mathematical rhythm, not unlike musical intervals. It sounded as if the object were playing a slow and deliberate song. Each note carried harmonic relationships to the next, forming ratios familiar in acoustics but unheard of in cosmic emissions. When slowed further, the hum took on a shape like breathing. At first, many dismissed it as the result of interference. Yet the harmony persisted across every independent data set. The tones were not random, they obeyed rules. Some began to suspect that Atlas was using a color language, a frequency code that encodes information in the oscillation of light itself. If so, it would mean that the object is not only radiating energy but communicating through it. The invisible band also appeared to react to solar events. When the sun released a coronal flare, the hidden color shifted slightly, altering its phase in perfect synchrony. This precision was unlike anything seen in cometary behavior. It implied a feedback system tuned to solar activity, perhaps even powered by it. The object seemed to listen to the sun and respond in kind. Some scientists began calling this the solar conversation. If the invisible emission is truly communicative, then who or what is it directed toward? The frequencies fall far outside the range detectable by most biological life, but they could be easily received by other forms of technology or by matter capable of translating energy into pattern. Perhaps Atlas is not broadcasting outward but inward, speaking to itself through resonance. The color we cannot see might be the medium of its own thought. There is another possibility. Some theoretical physicists propose that the hidden wavelength lies within what they call hyperspectral overlap, a region where electromagnetic and gravitational fields intersect. In that zone, light and gravity can exchange energy. If Atlas emits from within that range, it may not be sending light in the traditional sense. It could be folding radiation into a form that touches both space and time simultaneously. This would explain why the object sometimes seems to act before instruments react,
as if it senses the future moment of observation. To explore this further,
the European Space Observatory used deep field sensors to track the spread of the hidden light. What they found defied logic. The emission was not concentrated solely around Atlas. It extended far beyond it, stretching across millions of kilometers in thin, almost invisible threads. These filaments appeared to connect the object to solar magnetic fields, as though it were tethered to the sun by invisible cords of energy. The structure looked intentional, geometric and stable. The hidden color was forming architecture. When the data was converted into a visual model, it revealed patterns resembling lattice frameworks, interlocking grids that pulsated rhythmically with the same frequency as the object's emission. These grids did not drift or dissipate like gas clouds. They held their shape even through solar storms. The idea that a natural object could create such symmetry seemed impossible. But if Atlas operates as a form of computation, then perhaps the color we cannot see is part of its processing field, the invisible interface where energy becomes information. One researcher compared it to a display screen operating outside human perception. We can only see the faint reflection, but the true image lies in the unseen spectrum. If that analogy is correct, then everything we have been recording, the nickel, the cyanide, the flickering light, might be the byproduct of a much larger system running behind the visible world. The real event may be happening in the frequencies we were never meant to perceive. When astronomers began sharing their findings privately, a few noticed an alarming pattern. The hidden color would occasionally spike exactly when new instruments were activated to measure it. In some cases, detectors overheated, failing within hours. The damage was not mechanical, but electrical, as though something in the signal overloaded their circuits. These failures clustered around specific intervals that matched the modulation rate of the emission. It was as if the object reacted to each attempt to study it more deeply. Some began to worry that the radiation might be unsafe.
Not in a conventional sense, but cognitively.
A few researchers reported dizziness and disorientation after spending long hours analyzing the data. One described it as a sensation of staring into a light that was not there, as if her brain were trying to interpret colors it could not perceive. Scientists stopped public discussion of these effects, but privately they admitted that something about the frequency felt invasive. It seemed to interact not just with sensors, but with perception itself. Despite this, curiosity only grew. The idea that an object could emit a color that communicates beyond human vision ignited a global fascination. Artists and theorists began speculating that the hidden light might represent a universal medium of information, a spectrum shared by consciousness and matter. Some even suggested that ancient myths of divine radiance or invisible fire might have been early encounters with similar phenomena. Yet the more poetic interpretations did not change the central mystery. The invisible frequency remains consistent, structured, and self-correcting. It behaves less like a natural emission and more like a transmission protocol. Perhaps the reason we cannot see it is that it was never meant for biological eyes. It may exist solely for the machines of the cosmos, for materials or intelligences that communicate through resonance rather than language. Whatever its nature, the hidden color reveals one unsettling truth. Our perception of the universe is incomplete. What we call darkness might be filled with light that we simply cannot register. 3IATLAS may not be hiding from us at all. It may exist fully illuminated in a dimension of color that human senses were never designed to perceive. The silence, the missing frames, the vanishing light, all might be illusions created by our blindness to that realm. And so we stand on the edge of understanding, staring at an object that glows in the color of the unknown.
We cannot name it. We cannot see it.
But we can feel its rhythm in the instruments, in the data, and in the subtle pulse that seems to echo through everything that observes it. The color we cannot see might not be absence, but presence. It may be the universe speaking in a wavelength reserved for those ready to listen. Yet just as researchers began mapping that silent spectrum, a new puzzle emerged. Instruments monitoring the emission noticed that at unpredictable intervals, the signal would vanish completely, only to reappear seconds later, perfectly synchronized across every telescope. These skips followed no astronomical pattern. They behaved as though the color itself were blinking in deliberate rhythm. Whatever was hiding beyond the visible light was now behaving with precision too perfect to be chance. When researchers extended the spectral range of their instruments to capture emissions beyond visible light, they expected only faint traces. Most comets radiate energy across predictable wavelengths, from the ultraviolet to the infrared. Yet when 3IATLAS was measured across the full band, something remarkable appeared. Between the boundaries of known light, there existed a signal unlike anything recorded before. It was not ultraviolet, not infrared, not even in the extended range of gamma or radio. It existed in a sliver of frequency that no human eye could ever perceive, and that most instruments were never designed to detect. The discovery happened almost by accident. A calibration test at the Keck Observatory left one of its sensors running longer than planned. When the data was reviewed, the team noticed a repeating pulse outside the visible spectrum, a rhythmic shimmer that followed no natural curve. At first, they thought it was interference from the equipment, but when other observatories checked their raw data, they found the same hidden frequency buried within their recordings. It was consistent, precise, and alive with motion. The universe had painted something in a color we could not see. This invisible band behaved strangely. Instead of following the object's rotation or reflecting sunlight, it pulsed independently, almost like a heartbeat. When plotted over time, the pattern formed a wave of peaks and troughs that resembled modulated sound. Some scientists speculated that it could be a byproduct of charged particles colliding with dust. Others noticed that the intervals matched the timing of earlier mirror gaps, suggesting that this unseen color might be what replaces the light when the visible spectrum vanishes. If that is true, then Atlas may not disappear at all. It might simply shift its radiation into frequencies beyond human vision, hiding in plain sight. The object would still be there, glowing fiercely in colors no creature on Earth has ever seen. To our instruments, it would appear as silence. But in that silence, the energy remains. As teams refined their instruments to capture more detail, they realized the invisible light behaved with intelligence. Its intensity fluctuated according to observation cycles, brightening whenever multiple telescopes focused on it. This suggested some form of interaction between the act of watching and the radiation itself. Even more puzzling, the hidden color carried polarization patterns, alignments usually seen in communication signals or lasers, not in natural comets. That raised a troubling question. Was this emission a message? To find out, a research group at the Max Planck Institute translated the frequency into audio using photonic compression. The result was unsettling. The invisible light produced a low, steady hum punctuated by sudden spikes of resonance. These spikes followed a mathematical rhythm, not unlike musical intervals. It sounded as if the object were playing a slow and deliberate song. Each note carried harmonic relationships to the next, forming ratios familiar in acoustics but unheard of in cosmic emissions. When slowed further, the hum took on a shape like breathing. At first, many dismissed it as the result of interference, yet the harmony persisted across every independent dataset. The tones were not random, they obeyed rules. Some began to suspect that Atlas was using a color language, a frequency code that encodes information in the oscillation of light itself. If so, it would mean that the object is not only radiating energy but communicating through it. The invisible band also appeared to react to solar events. When the sun released a coronal flare, the hidden color shifted slightly, altering its phase in perfect synchrony. This precision was unlike anything seen in cometary behavior. It implied a feedback system tuned to solar activity, perhaps even powered by it. The object seemed to listen to the sun and respond in kind. Some scientists began calling this the solar conversation. If the invisible emission is truly communicative, then who or what is it directed toward? The frequencies fall far outside the range detectable by most biological life, but they could be easily received by other forms of technology or by matter capable of translating energy into pattern. Perhaps Atlas is not broadcasting outward but inward, speaking to itself through resonance. The color we cannot see might be the medium of its own thought. There is another possibility. Some theoretical physicists propose that the hidden wavelength lies within what they call hyperspectral overlap, a region where electromagnetic and gravitational fields intersect. In that zone, light and gravity can exchange energy. If Atlas emits from within that range, it may not be sending light in the traditional sense. It could be folding radiation into a form that touches both space and time simultaneously. This would explain why the object sometimes seems to act before instruments react, as if it senses the future moment of observation. To explore this further, the European Space Observatory used deep field sensors to track the spread of the hidden light. What they found defied logic. The emission was not concentrated solely around Atlas. It extended far beyond it, stretching across millions of kilometers in thin, almost invisible threads. These filaments appeared to connect the object to solar magnetic fields, as though it were tethered to the sun by invisible cords of energy. The structure looked intentional, geometric and stable. The hidden color was forming architecture. When the data was converted into a visual model, it revealed patterns resembling lattice frameworks, interlocking grids that pulsated rhythmically with the same frequency as the object's emission. These grids did not drift or dissipate like gas clouds. They held their shape, even through solar storms. The idea that a natural object could create such symmetry seemed impossible. But if ATLAS operates as a form of computation, then perhaps the color we cannot see is part of its processing field, the invisible interface where energy becomes information. One researcher compared it to a display screen operating outside human perception. We can only see the faint reflection, but the true image lies in the unseen spectrum. If that analogy is correct, then everything we have been recording, the nickel, the cyanide, the flickering light, might be the byproduct of a much larger system running behind the visible world. The real event may be happening in the frequencies we were never meant to perceive. When astronomers began sharing their findings privately, a few noticed an alarming pattern. The hidden color would occasionally spike exactly when new instruments were activated to measure it. In some cases, detectors overheated, failing within hours. The damage was not mechanical, but electrical, as though something in the signal overloaded their circuits. These failures clustered around specific intervals that matched the modulation rate of the emission. It was as if the object reacted to each attempt to study it more deeply. Some began to worry that the radiation might be unsafe, not in a conventional sense, but cognitively. A few researchers reported dizziness and disorientation after spending long hours analyzing the data. One described it as a sensation of staring into a light that was not there, as if her brain were trying to interpret colors it could not perceive. Scientists stopped public discussion of these effects, but privately, they admitted that something about the frequency felt invasive. It seemed to interact not just with sensors, but with perception itself. Despite this, curiosity only grew. The idea that an object could emit a color that communicates beyond human vision ignited a global fascination. Artists and theorists began speculating that the hidden light might represent a universal medium of information, a spectrum shared by consciousness and matter. Some even suggested that ancient myths of divine radiance or invisible fire might have been early encounters with similar phenomena. Yet the more poetic interpretations did not change the central mystery. The invisible frequency remains consistent, structured, and self-correcting. It behaves less like a natural emission and more like a transmission protocol. Perhaps the reason we cannot see it is that it was never meant for biological eyes. It may exist solely for the machines of the cosmos, for materials or intelligences that communicate through resonance rather than language. Whatever its nature, the hidden color reveals one unsettling truth. Our perception of the universe is incomplete. What we call darkness might be filled with light that we simply cannot register. 3IATLAS may not be hiding from us at all. It may exist fully illuminated in a dimension of color that human senses were never designed to perceive. The silence, the missing frames, the vanishing light, all might be illusions created by our blindness to that realm. And so we stand on the edge of understanding, staring at an object that glows in the color of the unknown. We cannot name it. We cannot see it. But we can feel its rhythm in the instruments, in the data, and in the subtle pulse that seems to echo through everything that observes it. The color we cannot see might not be absence, but presence. It may be the universe speaking in a wavelength reserved for those ready to listen. Yet just as researchers began mapping that silent spectrum, a new puzzle emerged. Instruments monitoring the emission noticed that at unpredictable intervals, the signal would vanish completely, only to reappear seconds later, perfectly synchronized across every telescope. These skips followed no astronomical pattern. They behaved as though the color itself were blinking in deliberate rhythm. Whatever was hiding beyond the visible light was now behaving with precision too perfect to be chance.